Assalamualaikum. Hello everyone. My name is Binti Jafar. First of all, thank you organizers for inviting me here today. I am honored to have the opportunity to share some information about the contribution of waste material to the properties of mortar in supporting sustainable construction. Sustainable constructions means structured with renewable and recyclable resources and materials. There are numerous ways in which construction players can improve sustainability include recycle and build with renewable or waste material. Recycling industrial waste in the construction industry can be a highly promising approach to sustainable growth. On the other hand, it helps to reduce environmental friendly method of waste disposal. My focus of this writing are mortar. Mortar is the example product composed by cementitious materials. Mortar acts as a binder to give strength to hold bricks of different size and to patch holes in building walls. Generally, for any brick strength, there is a suitable mortar strength that gives maximum strength to brickwork. Some materials consist of fine aggregate, ordinary Portland cement, and water. First, fine aggregate. Aggregates are important in construction industry because it acts as a reinforcement to provide the strength to the concrete. Approximately 60% to 80% of mortar or concrete composed of the aggregate. Second, cement. The basic ingredients of cement is combination of calcium, silicon, aluminium, iron, and small amounts of other chemical ingredients. Cement is important because it is largely affected in construction structure. Unfortunately, cement manufacturing consumes large amount of energy. Third, water is a major constituent in cement mixing process. Water acts as glue and it may affect the properties of the concrete, especially the strength and durability. What is the difference between cement and mortar? In the picture shown, mortar look like a thick paste. This is because mortar is a mixture of sand, cement, and water. Cement, on the other hand, look rough because it is a mixture of sand, cement, water, and coarse aggregate. Apart from that, mortar is used as a binder, while concrete is used for structure purpose. The difference also lies in the consumption of water during the mixing process, since mortar required more water than concrete. This slide shows the various materials used as aggregate replacement or partial replacements in mortar production. Three forms of material waste are usually generated are ash, fibers, or crushed material. Examples of materials waste in the form of ash include rice husk ash, tire rubber ash, palm oil clinker ash, and banana trunk fiber ash. In the form of fibers, PET bottles and nylon fibers from the cutting process are generated. The waste such as marbles, granite, porcelain tiles, and clay bricks in crushed form replace aggregate in the production of cement mortar. Basically, the waste used was obtained from crushing process were used until fine aggregate were obtained. It was important to keep the waste material at a constant size since the size distribution can affect the properties of the fresh and hardened mortar. Table shows a summary of the difference in the result of the study. It can be concluded that waste materials, whether in the form of ash, fiber, or crushed materials, can increase comprehensive strength, flexural strength, elasticity, and workability. In addition to the advantages mentioned, it was found that mortar made with recycled aggregate consumed more water to reach the same level of workability as conventional mortar because of the greater porosity of the recycled aggregate. Figures shows the optimal percentage replacement of waste materials in mortar production. Researchers use replacement percentage from 0.5%, 1%, and 1.5% up to 5% for ash and fibers, while 5 to 50% for crushed materials. Literature research shown that the optimal percentage for each materials is as follows. The mixture should not exceed this optimal value to maintain the functionality of the mortar in construction. It can be concluded that waste materials have great potential to be used in mortar mixing. Though it was found that mortar containing waste materials need more water to reach the same level of workability as conventional mortar, waste materials can still be used if the mixing ratio is correct. It should be noted that percentage of waste materials as cementing materials replacements must be within 1% to 5% only, according to type of particles, so as not to affect mortar workability, mortar compressive strength, and mortar flexural strength. That brings us to the end of the presentation. I like to summarize by saying that sustainable construction does not end after the completion of the structure, but the design of the structure should incorporate elements and materials that have a continuous influence on the structure's environmental impact. I sincerely appreciate your attention today. Thank you.